I'm a physiotherapist. I work in private practice at Steps Neurological Physiotherapy. I completed my physio degree in 2002. I'm following your lead, Darren. And completed my Masters in Neurological Physiotherapy in, I think, 2010. Right. Let's get started. So, what is a powered exoskeleton? So, as the term suggests, a powered exoskeleton is a powered wearable mobile machine which augments or assists human movement. So, they were traditionally designed for military application to help soldiers carry heavy loads, for emergency services to help firefighters or other rescue workers survive dangerous environments, and for medical applications to enhance precision during surgery, to assist with lifting heavy patients, and more recently they've been adapted to facilitate walking. So, here we go. Okay, so this is not a new concept. These images are patents for early designs of exoskeletons. On the left we have Russian inventor Nicholas Yagin, who in 1890 experimented with a giant bowspring, but finally settled on his compressed gas bags to store energy for his passive human-powered exoskeleton. And on the right we've got US inventor Leslie Kelly, who in 1919 developed what he called the pedometer, which operated on steam power with artificial ligaments acting in parallel to the wearer's movements. So this technology concept has been rumbling along for a while. If we have a look at a timeline of more recent years and jump forward to the 1960s, we can see the evolution of some fairly rudimentary mobile machines which are more integrated in human movement. So the Man amplifier had a powered gear system and was a pretty big unit. You can see some pictures of it. And the Hardyman suit was powered by hydraulics and electricity. It was co-developed by General Electric and the US military. And they reported this suit made lifting 110 kilos feel like lifting 4.5 kilos. Again, it was a really big unit. The suit weighed 680 kilos. It was never tested with the human inside. So then we move on to the 90s and the noughties. We start seeing the development of a group of products which are available commercially today. Some of these products have been designed solely for military application. But we're going to have a look at the 5 powered exoskeletons which are on or near to being on the world market for use by people with spinal cord injuries. So these are the 5 units in no particular order. We're going to have a look at some of their features. We're going to watch a video of each of them in action. The majority of the footage available for these products is in the form of promotional material. So we'll just keep that in mind and get ready for some inspirational music. So first of all, the HAL system, so the hybrid assistive limb, developed by Japanese robotics company Cyberdyne. The HAL 3 is their lower limb robot. It's got 2 different modes of action. So first of all, their voluntary control system, whereby the unit reads the user's bioelectric signals on the skin surface and compensates accordingly for reduced muscle power of lower limbs. So this essentially amplifies the wearer's motion. So this might be appropriate for someone who has an incomplete spinal cord injury, stroke, or another neuromuscular disorder. The second mode of function is their robotic autonomous control system, which is automatic motion support, basically full robotic powered movement. So that would be more appropriate for someone with a complete injury. The user specifications, they've got a max body weight of 80 kilos. Their height range is 4'9" to 6'1", and an 11 to 14 inch hip width, which is really, really narrow. So they were designed in Japan, and some of those characteristics flow through. The unit was primarily designed for use in rehabilitation centres. It was mass produced in 2012. There were 300 units across 130 medical facilities in Japan, and in 2013 it was given global safety certification, and they expanded into Europe. So the unit is currently available in Japan and Europe. It doesn't have FDA approval for sale in the US, and it doesn't have TGA approval for sale here in Australia. The weight of the unit is 12 kilos, which is light when we look at some of the others. Battery life is 90 minutes, and the cost is $2,000 US per month to rent the unit. So the HAL has been assessed in clinical practice, and I don't have time to go into a lot of these studies in depth, but just very briefly, and as mentioned, I will provide the references if anyone's interested in looking at these studies. Briefly, I'll go into two of the studies that I found around the HAL. ARC and colleagues in 2014 ran a pilot study of 8 people with chronic spinal cord injury, mean of 8 years post-injury. They included ASIA levels A, B, C and D. Injury levels were T8 to L1. So the participants participated in treadmill training with body weight support and the HAL3 unit 5 days a week for 90 days. They found significant improvements in overgrown walking, measured with a 10 metre walk, 6 minute walk, timed up and go, and they concluded that the unit was a safe and feasible means of gait training. In 2014, Nelson and colleagues ran a very similar pilot study with 8 patients less than 35 days post-stroke. They underwent treadmill training with HAL3 5 days a week until the HAL and the treadmill were no longer required. They found that the HAL system enabled safe, intensive gait training in hemiplegic patients with severely impaired gait function early after stroke. So the HAL system is the only system that I'm aware of that can be used just with the robotic limb on one limb. And so we're going to have a look at a video now of first a stroke patient, and then we're going to have a look at the second half of the video is a fellow with incomplete paraplegia, and you can see him transitioning through the gait rehabilitation with the HAL. There's very limited footage of the HAL units being used with people who appear to have actual impairments. Okay. So we'll move on now to the REX unit. Okay, the REX was developed by Rex Bionics in New Zealand. As you can see, it's quite bulky, both in the legs and the posterior pelvic component, but it is the only of the exoskeletons that doesn't require a gait aid. The unit allows the user to perform sit to stand, walk, turn, negotiate stairs, and all of these movements are controlled by a joystick. There is a rehab and a home use version. User specifications, we've got a max weight of 100 kilos, max hip width of 15 inches, which again is fairly narrow. And Rex describes the ideal candidate to be a manual wheelchair user who is able to transfer independently. However, the company does report success with users who are motor complete at C4 and C5 level. Whilst they do have a rehab and a home use version, what Rex have set out to achieve is their practice of robot-assisted physiotherapy. So essentially they talk about allowing therapy to be conducted in standing without the manual handling component of a therapist facilitating that standing. And that's what they call their robotic-assisted physiotherapy. So the rehab unit has FDA approval, so it can be sold in the States, but not here in Australia. And the home use version doesn't have approval, doesn't have FDA or TGA approval. The weight of the unit is 48 kilos, so it's a heavy unit, battery life of 2 hours, and a cost of $150,000 US. I wasn't able to find any clinical trials that have been published involving the REX unit. So we're going to have a look at a video of the REX. Okay, we're going to hear from Jared. And despite the lack of FDA and TGA approval, Jared seems to be using one of these units at home.
Hi, I'm Jared Pearce and I've been using REX for 3 months now. I've been in a wheelchair for 5 years now, and getting up and walking for the first time was something that I've always been trying to do since I had my accident, and it just blows you away to be able to get up and do that again. When I want to stand up, I just select stand on the menu, push the joystick forward, and then stand up. Same thing when you want to walk, you select walk, push the joystick forward again, and you're walking. It's that easy. Using Rex at home would be real beneficial for me in my own workshop at home.
Really slow stepping.
Engineering, and I do a lot of welding in my shed, and often burning my legs and using a bench and things that you can't really do sitting down, and standing up and getting into those proper positions you're meant to be in would help me a lot. For my partner to come and see me standing up for the first time ever, she's only known me in a wheelchair, and for her to stand up and get close and hug me, and that was a really good experience for us. I always said since my accident that I was going to walk before I was 30, which is about 6 months ago, and Rex has enabled me to do that in one way or form, and yeah, my friends just can't wait to see that too.
Okay, so that's the Rex. Next we're going to look at the Rewalk, and we're fortunate to be able to see this in action in a short while, and we can find out a lot more about the unit then. But it was developed by Argo Medical Technologies in Israel in 2001. It features motors that power hip and knee motion to allow the user to perform self-initiated standing, walking, and to negotiate stairs. The unit walks at around 0.4 to 0.8 metres per second, I believe, which is getting close to some of the speeds we need to cross a road, being 1.14 metres per second. Some of the evidence that we come across later also talks about walking speeds that they've found in research trials that they've done. User specifications. We've got a max user weight of 100 kilos, approximate height of 5'3" to 6'3", and a maximum hip width of approximately 18. But in talking to Jim and Steve this morning, there does appear to be some flexibility here. These specs aren't absolute. So like most of the other units, the user requires a gait aid, so hand function and reasonable shoulder integrity are required. Rewalk promotes its product for injury levels of T1 and below, but it has been used successfully for C5 and C6 complete injuries. There is two versions of the unit. There's the rehabilitation and the personal use version. My understanding is that the main difference between the two is in the Q angle, and in with the rehab version you get several different lengths of the componentry at the femur and at the tibia. The availability, both versions have TGA approval as of January this year, so they are able to sell the unit here in Australia. That TGA approval was gained through Making Strides, which is based in the Gold Coast, and that's where Jim and Steve have come down from, and we'll hear from them next. To my knowledge, there have been no units individually purchased or funded by compensable bodies here in Australia, but I'm aware that TAC have just approved trial of the unit. So for one of these units to be, for Israel to give a licence for a personal use unit to be sold, the client needs to undergo a training program that's based on competencies, and they talk about approximately 40 hours of therapist of gait training for those competencies to be achieved. But if you do achieve them earlier, you don't have to go through all 40 hours of that training. So the weight of the unit is 22 kilos, battery life of approximately 5 hours, and the cost of the personal use version is $79,000 and the cost of the rehab unit is $94,000 and training for the user is additional to that. So there are 170 units sold worldwide in the 2013-14 financial year. So these products are out there being used in clinical practice and by individuals at home. If we have a look at the evidence, and there certainly is the most amount of evidence around the Rewalk when we look at these five units. So I'll just touch briefly on a little bit of that evidence that I've come across. In 2012, Zielig and colleagues studied 6 participants with Asia A and B injuries at C7 to T12 levels. They were at least 6 months post-injury. They participated in gait training with the rewalk. And all participants gained the ability to walk 100 metres with crutches over an average of 14 sessions. There were no adverse effects, no increase in pain and no safety events. In 2012, Swansea and colleagues assessed the safety and performance of the rewalk in enabling people with motor complete spinal cord injury at thoracic level to complete routine ambulatory functions. They found the unit was safe, and following 24 sessions of 60 to 90 minutes over 8 weeks, most of their 12 participants reached what they describe as close to that needed for limited community ambulation. There was a high degree of performance variability across the individuals, some of which was explained by injury level, but there appear to be other factors influencing performance that were not able to be identified. In 2013, Feinberg and colleagues studied ground reaction forces in 6 people walking in the rewalk unit with Asia A and B injuries at T1 to T11 level. They were found to have similar ground reaction force profile both in magnitude and pattern to that of able-bodied walkers. Finally, Spungen and colleagues were interested in how long it might take to train the user to use the unit functionally. They studied 7 people with motor complete paraplegia, T1 to T12, and found that with an average of 45 sessions, the sessions were 1 to 2 hours long, all 7 participants learned to stand up, sit down, walk, and the walking speed over a 6-minute walk test ranged from 0.14 metres a second to 0.46 metres a second, so perhaps a little bit slower than the 0.4 to 0.8 speed range that's talked about, that I talked about earlier. 4 of the 7 participants learned to negotiate more than 5 stairs and achieved safe outdoor walking. So if we have a look at a video of the rewalk in action, I know we're about to see it in real life. The first person we see is a US Marine who was shot in Afghanistan. He's got a complete thoracic injury at what is described as chest level. And we'll have a look at that first. Oh yeah, I think there is.
The way it works is when I press the button to stand, and then once I'm standing, I press the button to walk. And once I press the button to walk, at that point, the steps will be triggered by my forward lean. So this sensor is, it's just like the sensor in your iPhone or any smartphone that senses the tilt of my forward lean. And so mine's set for 8 degrees. So if I lean forward 8 degrees, it'll trigger a step, take a step, and then, like I said, because walking is, a controlled fall, then I move from foot to foot. And so as I move from one foot, it senses that forward lean, then triggers the next step, and then it begins the cycle of walking.
Okay, so this video was taken by Darren up in strides. The guy you can see in the foreground, both of these users have got injuries about the T4, T5 level. The guy in the foreground, that's his first day using the unit, and you can see a lady in the background. I don't know if I can pull that back a bit. The lady in the background has been using the unit for about 4 years, so quite a bit of. There's a huge amount of gait training required for these units, but certainly there's the. Yes, so if I press play, you can see at the end here, you can see this lady walking a lot more fluently with the unit. Same level. Okay, we're going to talk next about the exosuit. So the exosuit was developed by US company Exobionics, which was founded in 2005. The exo features a series of modes whereby initially the therapist and then the user themselves initiate a step by pressing a button. There's an audio cue which tells you when ideal lateral and forward spatial targets have been achieved, which tells you when you should press that button to initiate the step, and then the user progresses onto the mode whereby the unit itself recognises ideal weight shift and initiates the step itself. They have a variable assist system with real-time monitoring of movement generated by the user. So it appears that this unit can allow for someone who is able to generate some of their own movement and do the rest for them. It was the first exoskeleton which was commercially available for rehabilitation. User specifications I don't have a lot of. They say it's appropriate for anyone with a C7 and below complete injury. It was primarily designed as a gait rehabilitation tool. There's only one version of it. They don't have a rehab version and a home use version. The unit is currently in use across the States and Europe. It does have TGA approval for sale here in Australia, but to my knowledge there aren't any units here in Australia. The unit weighs 23 kilos, battery life of 4 hours, and I wasn't able to find any information on costing, and I also wasn't able to find any clinical trials that have been published using the exosuit. If we have a look now at what Exo have got to tell us.
We have just introduced a brand new Exo.
We're revealing a new step mode. And so there's 3 modes that we can actually work in. The first mode is first step, that actually allows the therapist to initiate the step so they can train the new user while they're in the machine to feel where that balance point is, and then when they feel that they're at the right spot, the physical therapist actually triggers the step. The next progression is to active step, where we actually give the user the ability to trigger the step with their own button push. And so the user, while walking either with crutches or with a walker, when they feel comfortable, they can actually trigger and take the next step. And then the final progression is what we call Pro Step. And with Pro Step, the device itself can actually sense, just by the user's gesture and positioning, when that user has gotten into the right position, that knows they want to take a step, and it actually takes the step for them. So it's very transparent for the user.
It's amazing. It's freedom. I'm totally independent, and I don't have to rely on anybody else pressing the button for me.
Okay, last but not least, we're going to look at the Indigo unit. So the Indigo was developed by Vanderbilt University in partnership with motion and control-based technologies company Parker Hannifin in 2012. It's the newcomer to the scene. That company is based in Tennessee. It's a really slim profile unit. It doesn't have a backpack. It's got a modular design in terms of how you take it on and off. And that can be done independently by the user. The system can be controlled through a smartphone app, and they're currently developing FES integration into the shell of the unit. Like most of the others, we need functional hands and reasonable shoulder integrity for use of a gait aid. The user specifications, height range of 5'1" to 6'4", max body weight of 113 kilos. And they describe the unit as being appropriate for C5 complete injuries and lower. It was primarily designed for personal use. Its commercial availability is anticipated mid-2015 in Europe and late 2015 in the States. The weight of the unit is 11.8 kilos, which is light. The battery life is 4 hours, and I'm not aware of pricing for this unit at this stage. And I wasn't able to find any published clinical trials involving the Indigo. If we have a look at a video of the Indigo in action, more music.
We see the Indigo as being appropriate for anyone who has a neurological condition that's affecting their ability to use their legs. The possibilities are really endless.
So there's a lot of advantage to the exoskeleton technology, but specifically for Indigo, that sets it apart from other exoskeleton devices is the fact that it's so lightweight, it's modular, so it comes apart in 5 pieces, and that's crucial for somebody's independence down the road because they can transport the device by themselves, they can take it off by themselves, they can put it on by themselves. So that's a huge advantage for the person that may consider using Indigo. So the operation and setup of Indigo is extremely efficient. And that helps not only the person that's going to use the device, but it helps the therapist who's going to work with the person. So for a therapist to put the Indigo on, it takes about 5 minutes. And then we go through an instructional session with the patient telling them how it works. If they lean forward and they feel a vibration, after they feel the vibration, they'll stand up. Once they stand, as long as they lean forward, they will continue walking forward. And when they stop leaning forward, then they will stop walking. It's like a legged Segway, so it's extremely intuitive and very easy to learn.
Okay, So what might contraindicate a potential user from being an appropriate candidate for an exoskeleton? I wasn't able to find any information regarding definite contraindications from the companies who developed these products, but I did collate this list from the studies I came across which disclosed their exclusion criteria, and from chatting to Jim and Steve this morning. So first of all, contracture restricted normal gait movements, and that did vary a bit, and some of the studies specified flexion contractures not greater than 35 degrees and hip flexion contractures not greater than 20 degrees. Cardiovascular conditions incompatible with intensive gait training, skin pressure injuries, body weight and size limitations, recent bony fracture. We've got some bone mineral density and hip T-score information, which might be meaningful to some people. Severe spasms, which were defined as a score of 4 on the Ashworth scale. Lower extremity heterotrophic ossification, limiting hip or knee range, pregnancy and cognitive impairments. So the user really does need to be able to cognitively participate at a high level in the gait training process. If we have a look at some other considerations, I think probably the most obvious consideration with these products is the cost. They're made from expensive materials, they need to be strong and lightweight, and really there are low production numbers worldwide. We need to think about taking a team approach, whether we're looking at investing in these units for our rehab centres or assisting with individual prescription of a unit. I think we need to adopt a multidisciplinary approach. We need the medical team involved to help us address some of those contraindications we just looked at. We need a really thorough physio assessment to determine if the potential unit has the required joint range, muscle length, do they have the upper limb capacity required. We really do need to consider spasticity and know how the user's muscle tone is going to respond to the limb being passively moved at speed, and the list goes on. We need ongoing orthotic input for management of the device. As always, we need to work closely with the client and their family, and we need to work with the product suppliers. So there's a lot of people involved in the process. If we look at functional goals, I think it's important that we do. In my clinical practice, I work with people over the lifespan of their spinal cord injury, and I see people adopt the fastest, most energy efficient way of living their life. We've all just seen some videos of these products in action, and I think we can acknowledge that these powered exoskeletons are unlikely to be the fastest, easiest way of conducting all of your everyday mobility, but perhaps they will enable return to meaningful employment, or provide the opportunity to access environments that are simply not possible in a wheelchair. And I think we need to work really closely with our clients to determine what their functional goals are beyond walking for the sake of walking, and help clarify these goals. We need to look at evidence. We need to make sure we draw on the evidence-based knowledge that we already have if we're assessing the suitability for one of these products for our clinic or for an individual client. They really are amazing products, and we're about to, I'm sure you're all excited about seeing one in action, but there is a lot of promotional material out there, and I think that our clients can benefit greatly from our guidance when they're navigating their way through that information. In terms of future development, undoubtedly we'll see advancements in this technology in the near future, as well as the emergence of new evidence from clinical research studies to help guide our clinical decision making. So I just had a few acknowledgements. Jake Eady is a P&O at Austin Health and shared his presentation and timeline slide with me. Thank you. Christina, thanks for organising this evening. It's fantastic so far. And for Austin Health to allow us to use this facility. And as I said, I've got a list of references there which I'm happy to share. Thank you.